So here I'm trying to solve this equation, which means I'm trying to get x completely by itself. So I see that I have a variable on both sides. I have a variable term on that side and a variable term on this side. So that means I'm going to have to somehow combine those into one variable term on one side. So the problem is I can't actually just subtract 3x. Let's say I wanted to bring this over to that side. If I minus 3x from this whole side, it would cancel out. It would do its job there. It would cancel that out. But here I have this fraction that I'm not really just allowed to combine stuff. I'm not allowed to just throw that into the top here. It would really be rewritten as 4x minus 1 over 2 minus 3x. If I have subtraction here, that means I have to come up with a common denominator, which actually, it might not be that tricky, but I don't really want to have to do that. Even another way that you could approach this, you could split this. When you have a fraction like this, where you have addition or subtraction on top, you could split this into two separate fractions, where you divide this by 2 and you divide this by 2. I would simplify that. That would give me 2x minus 1/2 equals 3x minus 4. That's another way that you could do that. If you're comfortable keeping going from there, you could do that. But again, that's actually not even the way I'm going to solve it. The way I'm going to solve this is that I have this entire side divided by 2. That whole expression is being divided by 2, so to cancel that out, I would multiply by 2. If I do it on that side, I also have to do it to the entire other side. This entire expression needs to get multiplied by 2. Which means I'm going to have to distribute this 2 into that entire side. 2 times 3x will give me 6x. 2 times negative 4 will give me negative 8. And on the other side, all I'm doing is really canceling out those 2's. I'm dividing the entire expression by 2 and multiplying the entire expression by 2. Those operations cancel out and it leaves me with just 4x minus 1. Again, there's a bunch of different ways that you could approach this. That's the way I naturally see it, that if I want to cancel out an operation that's happening to the entire side, I could do the opposite of that. And if I do it on that side, I also have to do it on this side. Now I want to combine my variables to one side. I'm going to put my variables on this side, and I'm going to end up with my constants, or my numbers without variables attached to them, on the other side. So if I want to end up with my variables on this side, that means I have to cancel out this variable term on my left side, which means I'm going to minus 4x from both sides. That goes away. That gives me just a negative 1 left on that side. This gives me 2x minus 8. Now I want my constants to this side. That means I have to cancel out the constants on my right side. So I'm going to add 8 to both sides. That goes away. That gives me 7 equals 2x. That gives me one more step. 7 equals 2x. I'm going to divide by 2 on both sides. That cancels out. That gives me either 7 over 2 or 3.5. Could write it as a decimal or as a fraction. Either way, those are the numbers. That is the number that you can plug into this original equation to make it true. If you take 3.5 and you plug it in here and you plug it in there, you're going to get the same number on both sides. That's really what this equation is saying, that this expression will equal that expression with the true x value.